All right, so we now know what TP Animator is going to be doing, at least in this iteration of our character system. We also kind of saw a little bit of the future as to how we're going to be changing our move speed, but we'll talk about that in a later video. For now, all we're going to do is get our initial implementation of our TP Animator class.
Right. So let's get started. We're in Visual Studio 2010, if you're not familiar with it.
I think they've seen it a little bit.
A little bit?
Point.
You think so? Yeah, I don't know.
Yeah.
All right, so once again, we're back in Visual Studio. So let's go ahead and get a TP Animator class created. So we're going to create a new item. Give it a sec to come up. This is going to be a mono behavior. We've actually have our own little template that we've created before. We're going to call this TP_animator and hit add. Give it a sec. It should come up. Here we are with our initial sets for it. I'm going to get rid of these regions. I haven't been using them today, so I'm just going to kill them completely out.
Okay.
But I do have some methods in here. So I'm going to bring these out for now. Bring them up here. Save them for now. Get rid of this last region. This is just some initial groundwork to get the class where I want it to be to get started with. Now, just like all of our other third-person classes that we've been doing,
we're going to set up that static instance.
Yep.
All right. Well, let's go ahead and do that first.
All right. So we're going to create a public static, and this is going to be of type TP Animator, and we're going to call it instance.
And now that you have that, do you want to go ahead and put in the awake?
Yep. I'm going to switch
method?
start to awake.
And then go ahead and assign your instance.
Yep. And instance is going to equal this.
Now, technically, in this series, we have yet to go through that. But the idea here is just that we're putting into effect the ability to just call this by saying TP_animator.something.
Yep. So it'll be TP_animator.instance.whatever.
Whatever we want to reach into.
Right.
Right.
Now, there's a couple of things that we have to do before we really get into the meat of all this. Now, one, we were discussing about having a motion state or a direction state that we're going to keep track of.
Right.
To do that, we need to have an enumeration to hold all the possible combinations of directions that we're going to be looking for.
Just a list of those states.
Right. So
Literally.
what we're going to do is we're going to create a public enum, and we're going to call this direction. Now, inside of this enumeration called direction, we're going to have several states. Our first one is going to be stationary.
Forward, backward, left, and right.
Right. And then our combinationals.
So we'll start with left forward, then right forward, and then, of course, left backward and right backward. Oh, watch your capitalization.
Oh.
You hit the caps lock.
Yeah, I do that every once in a while.
Yeah, it's exciting. Left backward, right backward. And again, it's just an enumeration, meaning it's a list, really. I mean, I know there is a programming list, but that's what this is. It's just a list of all of our possible states.
Right. Now, because we have some states, we actually want to have a property that's going to hold that state.
Okay.
So what we're going to do is we're going to create that public direction is the type, and the property that we're going to store this in is called move direction. And that is going to hold the direction state for the TP Animator.
And it is a property, so you're going to put in the getter and setter.
Yep. So that gets our property in place. Now, we're not going to implement update, not yet.
All right.
So in our next set of videos, we're actually going to use the update. So I'm going to leave it here for now, but we're not going to use it.
I hear you.
We are going to use them is a method called determine current move direction.
And this is how we're going to set that property.
Right, and we're going to make it a public void method called, like I said, determine
current move direction.
Move direction. Now, it isn't going to return anything, and it's not going to take anything in as arguments. All it's going to do is try to determine the move direction state based off of the move vector that is held inside of our TP motor.
Well, it's going to do almost exactly what we drew out with all those curves reaching over to the D-pad with the checkboxes on it.
Yep.
As a matter of fact, the first thing you're going to do is make those checkboxes.
Right, so I'm going to make a bool forward.
It's like if you had an illuminated D-pad that lit up like when you pressed up and when you pressed right. These would be the lights.
Actually, I'm not even going to use bools. No, I hit the wrong button.
You're not going to do bools?
No, I'm going to do vars.
Okay. I was all excited because they were bools. Because then they really are like checkboxes.
Well, I know, but that's why I changed them. Because you were all excited
I was actually
about
too excited about it?
Yep.
All right.
That's like going, all right, I'm going to change it up on you.
All right.
Technically, they are still bulls because I'm setting them to false. So vars are going, hey, these are going to be bulls. So let's do var left equals false and var right.
So by default, we have no direction defined.
Yep. So until we know and we've validated everything, everything is going to be false. So the very first thing after setting up our checkboxes, if you will, is to figure out whether or not these checkboxes should stay turned off or if we should check them.
Just some quick if statements.
Yep. So if TP motor, we're going to go look for our instance of TP motor, and we're looking for our move vector. So we take our move vector. The axis that we're concerned with is our z-axis. We're going to check to see if it's greater than 0.
Which means we're moving forward.
Right. So if z is greater than 0, we're moving forward. So forward equals true.
Right. Now remember, way back when we defined z as the forward axis for the character, which means our left and right axis is going to be x.
So because this initial part is pretty much redundant, I'm just going to repeat it 4 times.
Yeah, that's a lot faster.
Or 3 times. So
I know what you meant.
If z is less than 0, then
backward is true.
Exactly.
Look at you not having to type anything now.
Yep. Now we need to check our x-axis. So if x is greater than 0 or x is less than 0. So if x is greater than 0, we are moving in what direction?
Should be left.
Yep. So we
no, it's right. I'm sorry.
It's right.
It's right. I just had to put myself into Cartesian space for a minute.
So if we're greater than 0, we're moving right. And I'm failing at double clicking. And the last one is going to be left.
Yeah. Process of elimination.
Yep. So now we've created our checkboxes. We've determined whether or not they need to be true or not. Now comes the fun part of going through and stepping out and figuring out those combinations.
Well, it's not too bad, really, because all we're doing is just saying, okay, for instance, the forward checkbox or the forward light is on. Are any other lights on? And really the only thing we have to check is left and right.
Right.
And if left is on, then we're going forward and left. If right is on, we're going forward and right. And if neither one of those are on, then we're just going forward, and that's it.
Yep. So we're going to skeleton the top level of it is like going if forward, we're going to do anything in here that we need to do if forward is on.
Okay.
Else, if backward is on, we're going to do some stuff that we need to do if backward is set to true. Else, if left is on,
which at this point would just mean if left was on by itself,
then we have to do something. And else, if right is on by itself, do something else.
And again, we know it would be by itself at this point because any other combination would be covered in the if statements for forward and backward.
Right. Else, if we've gone through all these conditions, the only combination left is not moving.
Yeah,
so
we're not moving.
We're going to drop down and set our move direction equal to
stationary.
Direction stationary.
Easy enough.
Yep. So let's go back up and flesh out some of this other stuff. So we've determined that the forward is checked. So
now we just need to check left and right.
Yep. See if left or right is on. So if left is on, then we must be moving left and forward. So move direction equals direction left forward. And there it is, left forward. Else, if right is checked, we must be moving in the right forward direction. Else, if left or right is not checked, we have to be moving in the forward direction. So move direction equals direction, not stationary, but forward. Now, let's clean this up a little bit. I don't need these extra brackets here. The same principle is going to apply for backward. So I'm going to copy and paste, but instead of left forward, this will be left backward. Instead of right forward,
Right backward.
Right backward.
And finally just backward.
Yep. Now, if just we've fallen through all the way to here and
all the combos
left,
are done.
Yep.
This would be just left by itself. So you could just set move direction to direction left. And then you could just copy paste that and change it to right, but you could do this too.
Yeah. I've done too much copying and pasting now, so
never. But we're done anyway.
Right. And because these are single lines, I don't need the extra brackets, so I'm going to just remove them. Keep things nice and tidy.
Sure.
Kind of reduce my line count if I can. Build out, see if I have any errors. There's no errors. So this should be all the implementation that we need, or it is all the implementation that we need for the TP Animator at this point in time.
Right. TP Animator is going to grow in importance and functionality as we move forward into the next series. For now, this is all we need and all we're going to be creating. So that is going to wrap things up for this video. Thanks a lot.